AS, KC, KP, right? And then we did this part last time. Okay, I told you there's a thing called KW, which is just KC for a very specific reaction. It's an equilibrium constant for a very specific scenario. वो scenario था कि अच्छा scenario ये था कि हर चीज water में हो रही है, and water ionizes a little bit, a very tiny amount of water ionizes, and it produces two ions. One is OH minus one, the other one is H3O plus one. उसका जो H plus one है ना वो टूट के इसके साथ जुड़ जाता है. So it ends up producing two ions, or you can say that the simplified version is water breaks down, produces two ions. One is H plus one, the other one is OH ions. Since it's an equilibrium reaction, even though the equilibrium is heavily favoring the reactants, बहुत ही कम ions बन रहे हैं, ठीक है? So it's almost very negligible. But so Kc का जो expression है वो ये आ जाता है, product concentration divided by reactant concentration. The reactant is water over here in both cases, but since water is in large excess, its concentration is assumed to be constant, which is why the expression that we get for Kw, which is the equilibrium constant, is just the ions getting multiplied. ठीक है, बस इन दोनों का product है. This is also known as the ionic product of water. Or that's Kw, and Kw has a constant value. That value does not change. It's like an equilibrium constant. It's got a constant value, which is कि pure water के अंदर at 25 standard conditions, it's 1 times 10 power minus 7. The other ion is also 1 times 10 power minus 7 mole per dm cube. If you multiply the two, you get 1 times 10 power minus 14. And that's constant. That's Kw is constant. No matter what you do, the equilibrium value will not change unless temperature up change करते हो, ठीक है? Only changes with temperature. If you increase H plus 1 ions, the OH ions will automatically decrease, but the product will still come out to be 1 times 10 power minus 14. Vice versa, if you decrease H plus 1, the OH ions will increase, and the product will still come out to be 1 times 10 power minus 14. So जो मर्जी करो, the value will be constant. And that's what Kw is. तो अगर आपको acid दिया हुआ है ना, you can, if you know the concentration of H plus 1, you can figure out the concentration of OH ions by using this expression. But better still, आप क्या करते हो? You take the log of both things. ठीक है, जब आप log लेते हो and you take the negative log. When you take the negative log turns this expression into negative log of H plus 1 concentration into negative log of OH ion concentration. That is equal to, इसका negative log लेते हो, you get 14. This negative log is known as P. P कहीं पे भी होगा ना, that's negative log. And so this is pH and this is pOH. pH plus pOH is equal to 14. Log लेने का मैंने वो बताया था कि you can make very nice graphs. So if you're tracking the concentration of H plus 1 and OH ions in a solution anywhere, तो वो जो log लोगे ना, उसका फायदा ये होगा कि ग्राफ अच्छा बनेगा, ठीक है? And then we learned how to calculate the pH for strong acids. It was pretty easy. Strong acid, you already know the concentration of H plus 1 ions because it fully ionizes. So अगर HCl 0.2 mole per dm cube है, then H plus 1 will also be 0.2 mole per dm cube, and you can just take the negative log of it and you'll get the pH. That's about it. Similarly, nitric acid has the reverse pK. अगर वो 0.0001 mole per dm cube है, then H plus 1 will also be the same, and you can just calculate the pH. That's it. Take the negative log of it. Then we learned how to calculate the pH for strong bases. So in strong bases, you don't actually calculate pH. What you calculate is pOH. Okay, agar NaOH 0.02 mole per dm cube hai, then this will also be 0.02 mole per dm cube. And वो भी 0.02 mole per dm cube होगा. And using that, you're going to calculate pOH, which is negative log of OH ion concentration. Once you do that, finding pH would be easy because pOH plus pH is equal to 14. So pH would be 14 minus pOH. So ये हमने निकाला था. और मैं रिवर्स भी किया था कि अगर pH दिया हुआ है and they're asking for the concentration of KOH, what do? You immediately, first thing, you forget pH, you try to find out pOH. Once you found POH, तो उसका inverse ले लो, anti-log. And I told you how to do that. Like if POH is 0.9, so that means OH is 10 to the power minus 0.9. ये चीज याद रखना कि conversion, it's pretty important that if you know something has a pH of 12.3, then that means H plus 1 will be 10 to the power minus 12.3. Okay, it's just, yeah, calculator, it's just shift and log. That just turns it into anti-log. So ये दोनों करने आने चाहिए. So we did all of that, and we can just do one more, maybe one more question. Okay, let's say that question is कि so that question is, let's say barium hydroxide is a pretty strong base and it fully ionizes. ठीक है, तो एक और क्वेश्चन कर लेते हैं. So अच्छा, assuming barium hydroxide is a strong base, so assuming BOH2 is a strong base, what you have to do is the pH of barium hydroxide is given as 13.1. And they are asking you to find concentration of barium hydroxide. Like, what's the concentration of barium hydroxide in this particular solution if it's got a pH of 13.1? First thing, for bases, you don't deal in pH. What you do is you convert that into POH plus pH is equal to, so that's equal to 14. So immediately you convert the pH into POH. POH kya hoga? That's going to be 14 minus what? Minus the pH, which is in this case 13.1. Actually, the weak question aa gaya, 13.1. So it's going to become 0.9. So that means POH is 0.9. Negative log of OH ions is 0.9. So OH ions will be equal to 10 to the power minus 0.9. Okay, do this directly and you'll get क्या value आ रही है 10 power minus 0.9. What do you get? किसी पास है calculator? अच्छा 0.126 is 0.126 mole per dm cube. अच्छा 0.126 mole per dm cube, and अब अगला जो part है ना वो ये कि if it's 0.126 mole per dm cube उसका करना है, how do you figure out the barium hydroxide concentration? The way you're going to do that is कि उसने कहा था कि fully ionized, assume that it fully ionizes, so it's going to be barium ions plus 2 OH ions. So we figured out the OH ion concentration, which is coming out to be 0.126. So that's coming out to be 0.126 mole per decimeter cube. So the barium hydroxide concentration will be half of that. So what is half of that? That's 0.063. So half of that is 0.060 mole per dm cube. That's about it. The question, actually, question is this clear? The first part, is this clear? Okay, how do you calculate pH for strong acids, strong bases? Yes or no? Is this clear? Abia, Anna, Alicia, Hasib, is this clear? Read clear?
Yes.
The 0.063, as a 0.063 is just half of that. Na, okay. They gave us the pH. उसको मैंने pOH से बना लिया, ठीक है, and I from pOH I was able to figure out the OH ion concentration. So since I figured out the OH ion concentration, तो barium hydroxide कितने OH ions produce करता है? It's 2, right? So I figured this out. The moles, it's 2:1, right? So the concentration of barium hydroxide would be half of this. I'm assuming half of this is this. ठीक है, see, is this clear? अच्छा, next part. अब ये next part है, that's where weak acids start. ठीक है, the problem with weak acids is they don't really ionize. ठीक है, so weak acids they ionize very weakly. अच्छा, we're not going to do weak bases, by the way. ठीक है, so अच्छा, weak acids. The definition is that they partially ionize and produce and in the process they donate fewer H+1 ions. So now we have a problem that if you had HCl, right? Now HCl was a strong acid. HCl would fully ionize and it will produce H+1 and Cl ions. तो यहाँ पे तो कोई problem था ही नहीं. pH calculate करना was pretty easy. It's like if this is 0.25 mole per dm cube, then H+1 would also be 0.25 mole per dm cube. और आपको क्या करना है? आपको सिर्फ ये करना है कि you just have to figure out pH. Just take the negative log of this thing and that's about it. So it's a pretty easy question. pH would be negative log of 0.25 and that's about it. जो भी वो value आ रही है, ठीक है? So it was kind of easy. But when you have a weak acid, and who are your weak acids? Weak acids are अच्छा, 2-3 types के weak acids हैं, ठीक है? So you've got organic acids, mostly organic acids. Organic chemistry में ना आगे जाके you'll study 3 organic acids, 3 of them. There's carboxylic acid. But all organic acids are kind of weak acids. Okay? So carboxylic acids, you've got phenols, which you probably don't know right now what they are. Actually, even alcohols are slightly acidic because they also sometimes lose H+1 ions. Okay? So most organic acids, they are kind of weak acids. Plus there are acids known as acid salts. Okay, they are also weak acids. एक तो ये हो गया organic. That's number 1. And number 2 is acid salts. So what are acid salts? Acid salts are formed when an acid is not completely neutralized. How is an acid neutralized? If you have H2SO4, तो आप उसके अगर H खत्म कर दो ना, तो it will become a salt. It will become Na2SO4, for example. Okay, so why is that a salt? Because the acid part has been completely eliminated. it no longer is capable of producing H plus one ions. क्योंकि है ही नहीं, अब exist ही नहीं कर रहे H plus one ions. So how will it produce H plus one ions? So that will not happen. So that's H2SO4 and this is Na2SO4. So that's complete neutralization. Sometimes there will be incomplete neutralization. So ये वाला part जो है, that's so this part is complete neutralization. Or sometimes what will happen is you'll have H2SO4 and that H2SO4 will turn, both hydrogen ions will not get replaced. Instead, only one might get replaced. The other H is still hanging in there. Okay, so that is your acid salt. Because it's still capable of producing an H plus one ions. And even though it is partially ionized. So incomplete jab hogi na neutralization, incomplete. So that ends up with something that's in between. That's partially an acid and partially also a salt. थोड़ा बहुत neutralize हो गया, थोड़ा बहुत neutralize नहीं हुआ, ठीक है, still capable of producing H plus one ions. So these ions over here, ये जो HSO4 minus 1 का जो ion है ना, that's these ions over here, especially HSO4 minus 1 ions, they are your salts, okay, and they're your acid salts. But the idea clear है acid salt का? Is this clear? कि हम किस चीज को acid salt कह रहे हैं when it's incompletely neutralized, ठीक है? For example, HCPO4 होगा ना, तो HCPO4 is capable of forming two acid salts. Like you have now HCPO4 is your acid. तीन में से दो H, एक H चला गया and it gets replaced by Na plus 1 and the other one is H2PO4. So that's an acid salt. Another acid salt could be that two of the hydrogen ions get displaced by sodium and there's still one left. और तीसरा होगा कि all three of them are gone. So it ends up forming NaClPO4. अच्छा, anyways, these acid salts, ये तो end में बिल्कुल ही salt बन गई है, बीच वाले acid salts हैं, ठीक है, this one is an acid salt. अच्छा, but थोड़ा सा इसको थोड़ा सा deep dive कर लें कि why do acid salts, why are they weak acids? तो होता ये कि when you have phosphoric acid, अच्छा होता ये कि when you have phosphoric acid, तो the phosphoric acid doesn't lose that H plus 1. उसके पास 3 H plus 1 है. इसको मैं थोड़ा सा और expand कर लूं कि why are acid salts weak? कि why don't they like to lose H plus 1 ions? So this is what HCPO4 kind of looks like. It's P is making a double bond with oxygen and it's making single bonds with OH, 3 OH groups. एक इधर है, one is on the left side, and then you've got one which is at the bottom, ठीक है? So you've got, that's what HCPO4 is. And it's got 3 H plus 1 ions. Bari bari na, it actually loses those 3 H plus 1 ions. But it's not going to happen in one go. Like हम तो लिख देते हैं ना कि HCPO4 अच्छा हम हमेशा लिख देते हैं कि we just write कि HCPO4 loses all the three H plus ions in one go. Okay, we have a tendency to write this. But this is not how it actually works. Okay, वो तीनों H plus ions it doesn't lose in one go. होता ये कि पहले one of the H plus one breaks off. ठीक है, somebody gains it. तो that H plus one, let's say, leaves. ठीक है, ये जा रहा है और ये -1 बन जाता है. ठीक है. So it happens stepwise, and the steps are. तो पहला step ये होगा कि H3PO4 loses just one H plus one and ends up forming H2PO4, and it's got a charge of -1. I said, then what happens is that someone else comes in and steals one of the other H plus one ions. Okay, so another H plus one decides to leave. And this oxygen now becomes -1 as well. So now what has happened is you had H2PO4 -1, and it loses another H plus one ion. Or when it loses that, it becomes HPO4, but now it's got a charge of -2. अच्छा, फिर क्या होगा कि the last H plus one also, someone else comes in. So stepwise over, it's not happening together. The last H plus one comes in and it also decides to leave. तो फिर वो जो एक H बचा हुआ था ना पीछे, वो भी चला गया. So it's HPO4 -2. And the last H plus one also leaves, leaving you with just PO4 -3, right? So this is all happening stepwise. It's not happening in one go, it's happening stepwise, one by one. ये वाला idea clear? Is this part clear? So remember this, acids dissociate or ionize stepwise. They don't just go crazy and lose all the H plus ions in one go. They do it stepwise. ठीक है? अच्छा, लेकिन अब इससे तो इसका मतलब है what that means is, now focus on this thing. Phosphoric acid. Don't think of phosphoric acid as one acid. ये जो phosphoric acid है ना, it's not actually one acid. It's actually three different acids. क्योंकि जो पहला H plus one lose किया था ना, that was lost by H3PO4. The second H plus one was lost by another species, which is H2PO4 -1. And the third H plus one was lost by HPO4 -2. So phosphoric acid is not actually one acid. It's actually three different species that are losing H plus one ions. Okay, and all those three species are behaving differently. Okay, so the idea clear है, don't think of phosphoric acid as one acid. Every time, if whenever it decides to lose another H plus one, it's a different species. उसके ऊपर negative charge है. ये तीसरा H plus one was lost by someone who had a -2 charge. Okay, the first H plus one was lost by a molecule that was neutral. So treat them as three separate acids and three separate dissociations, not as one thing. Okay, not as one thing. It's three totally different reactions. So which one do you think out of the three is the strongest acids? For which one is the ionization going to be the easiest? In तीनों में से. And focus on the negative charge. Remember, the first one is neutral, the second one is -1, and the third one is -2. तो कौन सा जो H plus one easily lose करेगा और कौन सा जो H plus one बहुत मुश्किल से lose करेगा? ठीक है, first the first one will be the easiest because -2 ion जो है ना that will, because it's got a very negative charge, it will instead attract H plus one ions instead of losing H plus one ions. तो acid की जो strength है ना, that becomes weaker and weaker. Losing the first H plus one was easy. Losing the second H plus one was even more difficult. Losing the third H plus one, इसके ऊपर देखो -3 का charge आ गया total. When you have a -3 charge, तो वो तो दूर जाने की बजाय वो तो उल्टा वापस आ जाएगा, ठीक है? So it would be very hard to actually lose H plus one ions. So what happens is that the dissociation becomes more difficult as the negative charge increases. So dissociation becomes a lot more difficult. Increases on the ion. That's the reason why they're becoming weak acids. HPO4 minus जो है ना वो weak acid इसलिए क्योंकि उसके ऊपर negative charge है. It's not going to lose H plus one that easily. ये उससे भी weak acid है because it's got a charge of -2. So it would be a lot harder for it to lose H plus one ions. So remember, for diprotic and triprotic acids and जिनके पास एक से ज्यादा H plus one होता है, it's always the losing the first H plus one is easy. The other ones, it becomes more and more difficult. ये idea clear है? ये clear है? इस पे तो कोई question नहीं है. Alicia, Anna, Ray, this is clear. Shahan, Umar, clear है? अच्छा अब ये कि ये मैंने खाली एसिड सॉल्ट्स का बता दिया कि वीक एसिड्स हम बस डिफाइन कर रहे थे. The other ones is organic acids. We're going to discuss the organic acid in a lot more detail in जो आपकी वो है organic chemistry. लेकिन इसको हम यहाँ पे भी डिस्कस कर सकते हैं. We can, लेकिन that will kind of deviate, so we'll probably not discuss. There'll be a lot of questions actually on this. Why is the acid strength varying? ठीक है, मैंने अभी acid salt का explain to you. There are a number of factors why some acids are weak and some of them are strong. But we're going to ignore this part right now. ठीक है, because we haven't studied phenols. So it will be kind of pointless to even discuss the variation in acid strength in organic chemistry. But we'll do that in organic chemistry later on. अच्छा वापस आ जाते हैं weak acids. First thing, they don't ionize completely. It's very hard for them to actually lose H plus one ions. ठीक है? So for example, if I have ethanoic acid, so that ethanoic acid is, for it would be pretty difficult for it to lose H plus one ions. So not an easy job for it to. तो ये हो गया CH3CO -1 plus, अच्छा plus H plus 1, right? अच्छा this one, not easy for it to lose H plus 1. So the difference between a strong acid and a weak acid is कि strong acid तो fully ionized कर लेगा, it's a strong acid. But if I have 0.25 mole per dm cube, so H plus 1 is not going to be 0.25 mole per dm cube. It's going to be a lot less than 0.25 mole per dm cube. Okay, so that is what happens when the ionization is weak. The first one was strong, but the second one is kind of very weak. Okay, so pehla the problem is how would you calculate pH, because you will not know what the H+1 concentration is to begin with. उसका इतना आसान काम नहीं है कि वहां पे बस पता लग गया H+1 क्या है. ठीक है, तो यहाँ पे मसला है कि ये नहीं पता कि H+1 concentration what is it going to be. अगर तो वो fully ionized करता it would have been 0.25 mole per dm, but it's not. Only a small portion of it is actually ionizing. So we have no idea. There's a big question mark on this. So we've got no idea what this is. तो एक तो पहला problem सबसे पहले ये आ गया. ठीक है, no idea what this is. And since we have no idea what this is, what we'll do is, what we're going to do is, okay, it's an equilibrium reaction. तो हम इसको उठाते हैं. अच्छा, ये clear है ना कि मसला क्या है, strong or weak में? Is this clear? क्योंकि H+1 का पता ही नहीं लगेगा इसमें. ठीक है, तो strong वाला case simple है. अच्छा, and remember this is not the full equation for a weak acid ionizing, because I told you that what actually happens in reality is it's this equation which is mostly not used. Lekin jo full equation it's this one, okay, the acid loses an H+1, and who gains it? It's the water in the solution that actually ends up gaining that H+1 ions. तो वो उल्टा ना H+1 gain करता है. So you've got CH3CO -1 plus H3O +1. Sorry. अच्छा, ये आपकी actual equation है. ठीक है, remember I told you earlier that in water the H+1 actually gets attracted to water molecules, ends up forming H3O +1. So that's your actual equation of a weak acid ionizing. Okay, which is this one. But both of them are kind of the same reaction. It's people often use this one and not that one. हम दोनों के साथ ही कर लेते हैं, you'll get the same exact expression. अच्छा, it's an equilibrium reaction. And I'm going to generalize this. The general reaction is okay, every weak acid is going to be thought of as HX. And it's going to ionize. And when it ionizes, it's going to produce an H+1 and some random negative ion like X-1 ions, right? Yeah, अगर इसको इस form में भी लिखना है, it's going to be the same thing. It's you're going to consider every weak acid as HX. It's H+1 attached to something. वो water के साथ react करता है, gives its H+1 to water, and पीछे रह जाता है X-1 and H3O +1 is formed. अच्छा, H3O +1 is formed. So all weak acids will kind of be treated in the same way. As a reason, इसके अंदर there's one H. मेरी जो general equation है, it's got one H. और मैं weak acid को ना, I'm assuming it's always going to release one H+1 ions, whether it's this one or this equation, it's kind of the same equation. Why am I saying that? Because I'm not treating phosphoric acid as releasing 3 H+1 ions. वो देखो हर दफा ना it's HX produces an H+1 and produces some negative ion which is X-1. ठीक है, this is HX releases one H+1, produces some random negative ion which is X. So every time when I talk about acid dissociation, weak acid dissociation, I talk about losing one H+1 ions. I don't talk about losing 3 H+1 together. उसको मैं 3 अलग-अलग steps में consider करूँगा. ठीक है? So it's always, whenever we talk about weak acids, it's all about losing one H plus one ions. और फिर अगला step होगा. Maybe if there's another H plus one, it's going to lose that other H plus one as well. But we will only talk about losing just one single H plus one ion. ठीक है? तो ये बात clear है. हमारी जो general equation है ना, it's always talking about losing just one H plus one. Is that clear? और इधर से फिर हम आगे चलेंगे. तो remember this, whatever the weak acid is, think of it in this way. लेकिन only one H plus one. Phosphoric acid, think of it as three acids. First one loses H plus one, you get this reaction. Second one loses H plus one, that's a separate reaction. Third one loses H plus one, that's a separate reaction. But every time it's going to be, you're going to use this equation, ठीक है? तो इधर से कल कंटिन्यू करते हैं इसका करना क्या है कि क्योंकि मसला तो ये है कि ये H plus one किस तरह पता लगेगा कि how much does it ionize, we have no idea. तो फिर कल डिस्कस करते हैं, ठीक है? चलिए सारों को क्लियर, रीड क्लियर है, सी शान दीक्षा है ना, इज दिस क्लियर? चलें, ओके देन, ठीक है एवरीवन, अल्लाह हाफिज.